Okay, good morning, everyone. I hope you can hear me. Okay, I'm way on course today. That's why this is a recorded video. Okay, before we begin, make sure you have logged into your class cake. Okay, and we are looking at set number 11. Okay, so in the meantime, please make sure you log into your class cake now and load the set of notes, set number 11. The title is called Kinetic Particle Theory Graph. Okay, I'll share my screen now. Okay, if you have not loaded the class cake, please do so. If not, you can still pause the video. And once you have loaded the class cake, you can resume the video. Okay, for those who are done, we will begin now. Okay, this is the set of notes for kinetical particle theory. The title is called graph. Okay, graph is very important for this chapter. Okay, the reason is because there will definitely be graph to test you on this chapter. For graph, you do not need to sketch, you do not need to plot. Okay, but however, there are important things that in the graph they will ask you. And there are a few graphs for this chapter. Okay, so let's look at all the possible graphs for this chapter. Okay, first of all, what are the graphs that we're talking about? Okay, our focus today over here is about the change of state. So we can use a graph to represent a change of state. What is a change of state? If you recall from our previous lesson, okay, the change of state basically means melting. That means you change from solid to liquid. That's also a possible change of state. If not, you can have boiling, you can have freezing, and so on and so forth. So all these boiling, freezing, melting, condensation, sublimation, all can be represented using a graph. Okay? So for the graph, the important things to take note of the graph is the x and the y axis. Okay? So for a graph, the x-axis is time. Usually the times is in seconds, if not minutes. Okay? The y-axis is temperature. You can also copy it down on your class cake. Okay, if you need more time to copy, you just pause the video. Okay, so the y-axis is temperature, the unit is degrees Celsius. So there you have the two axes for the graph. Okay, let me introduce the 4 different graphs that you'll be seeing later on. The number 1 is called a melting curve. Number 2 is called a boiling curve, followed by freezing and condensation. So there are total of 4 graphs. If you look under the category, let me get my highlighter. Okay. There's this thing called heating and cooling. I trust you know what's heating. The opposite of heating is cooling. So heating curve means the temperature goes up. Temperature will keep on increasing. Temperature increases. That is called heating. I think common sense, because when you heat something, the temperature definitely will go up. Cooling curve indicates that the temperature will go down, decreases. So when you see the graph later, if you see that the temperature is going up, the temperature increases, it means it is a heating curve. On the other hand, later when you see the graph, when the temperature goes down, the temperature decrease, that is a cooling curve. Okay, any questions so far? If you need more time, you just pause the video, fill in the blanks. Okay, so for heating curve, let's start with the heating curve. Okay, this is the first one, number 1. It's called a melting curve. So there are two heating curves. There are two heating curves, melting and boiling. Okay, number 1 and number 2, they are both heating curve. So for melting curve, what is it talking about? It's basically solid melt become liquid. So that's called a melting curve. Very straightforward. Solid to liquid is melting lah, and I call this melting curve. So as you can see, the temperature increases. Okay, you can observe that the temperature goes up from 20. It starts at 20. It ends up at the maybe 80. So temperature goes up. We call this a heating curve. Okay, to be more specific, it is a melting curve because the thing is melting over here. So on the graph, let me just erase all the things so that we can refocus back on the graph. Okay, on this graph, you will see numbers. I need you to take note of this number. This is a very important number. I draw a dotted line. Okay, this dotted line starts from the horizontal part of the graph, PQ. Okay, and it ends up with this number 65. What does this 65 means? This 65 indicates that this is the temperature at which melting will start. In other words, at 20, the solid have a melt. 30, the solid also have a melt. 40, the solid also still solid have a melt. Only until 65, then the solid will start to melt. We call this the melting point. So that's why it's indicated on the graph as horizontal segment. That is also the melting point, and that's also the temperature at which the solid starts to melt. So I have this thing over here, PQ. PQ is the horizontal part of the graph. Okay, so at PQ, it starts melting. There's a change of state from solid to liquid. Okay, so let me change my color of my stylus. Over here, I have a solid plus liquid. Over here, I have solid only. Over here, I have liquid only. Okay, so you must take note. There are 3 parts of the graph. The first part is solid. The second part is solid and liquid. The last part is liquid. Okay, why? Because they will test you. Where is the solid? Where is the liquid? Where is the mixture of solid and liquid? So when it's melting, it makes sense that when it's melting, some of the solid turns to liquid, while some of the solid still have a melt. So it's a mixture of solid and liquid that is happening at 65 degrees Celsius. Okay? So melting takes place or melting starts at 65 degrees Celsius. The melting point is 65 degrees Celsius. Any question? If not, let's move on to the next heating curve. This is also a heating curve because the temperature is going up. You are heating it. But over here, if you check carefully, it's boiling. Okay, if you check carefully, it's boiling because the liquid is becoming a gas. Okay, liquid is becoming a gas. So over here, I have also a special number, which is called the boiling point. The boiling point of this substance, K, is 120 degrees Celsius. What does that mean? It means to say, at other temperature, maybe at 80, 90, 100, it haven't boiled. 110 also haven't boiled. Only at 120 degrees Celsius, then the liquid starts to boil. So I will write over here, at 120 degrees Celsius, the liquid will start to boil. And I call this the boiling point. So for liquid K, the boiling point is 120 degrees Celsius. It is indicated by a horizontal segment of the graph. So boiling point of K is 120. Boiling starts at 120 degrees Celsius. During boiling, there's a change of state. Okay, so there's a change of state. So over here, 3 sections. From here to here is liquid plus gas. After that, after you boil finish, it's gas. Before you start boiling, it's liquid. Okay, so it makes sense. Before you start boiling, you reach 120, then you start boiling. Before you reach 120, it's liquid, haven't boiled. When you reach 120, it will boil. Boil finish, then the temperature become higher. It now all gas already. Can? Okay, let's take a look at this practice question. Okay, over here, I have a graph. First thing first, this is a heating curve. Because I can see that the temperature is going up. Okay. Next, is this melting, boiling, or what? I don't know. What I do know is I'm given water. So it means to say I start with liquid. Because water is a liquid, right? Okay. I start with a liquid and I'm heating a liquid. So when you heat a liquid, there's only one outcome. The liquid will boil when you heat the liquid. So when I heat the liquid, it must of course become gas lah. I mean, it makes sense when you heat something, it gets hotter, the liquid will start to boil, then it becomes a gas. So over here, they ask you, first question, state the boiling point of water. The boiling point of water is 100 degrees Celsius. Remember to include the units. Okay, you must. Don't forget my units. Okay, boiling point of water is 100. Everyone knows pure water boils at 100. Now I want you to indicate on the graph the boiling point of water. So you go and estimate. If this is 25, okay, where is 100? It's a bit tricky. You may think that 100 is very high, but actually it's over here, 100. Why? Because I mentioned that the horizontal segment of the graph represents the change of state. So it represents boiling. So you look for the horizontal segment of the graph. And after that, you draw a dotted line and you indicate that as 100. So I know that over here at 100 degrees Celsius, the substance, liquid water is boiling. Okay. So I done part A. I also have done part B. I've labeled on the y-axis 100 already. Part C, I think they want you to label 3 parts, RS, ST, and TU. So what's RS? RS represents the liquid. So where is the liquid? You can divide the graph into 3 parts. Okay, I divide the graph in 3 parts. The middle part is the horizontal segment. So now I have 3 parts. And I want the liquid portion. So naturally, this must be liquid because I haven't boiled. Only during boiling, there is liquid and gas. Logical? That's boiling. Then after you boil finish, all become gas. Okay, I hope the 3 segments of the graph indicated in blue, you can recognize them. What is liquid, where is gas, where is liquid and gas. So I want RS. RS represents the liquid. So I will label R is here, S is here. Okay, I plot R is here, S is here. So R and S, that is the liquid. From R to S, that segment, whole segment is liquid. Next one, let me change a different color. Choose green. ST. ST is liquid N gas. So I know that S is over here, T must be here at this point. So from S to T is boiling. That's why I have liquid and gas. Okay, some liquid boil already, some liquid haven't boiled. So it's a liquid and gas. It's still boiling in the process. Okay, next one, TU. Let me change a different color. Let's choose purple. TU is only gas. So I see that this is T and that will be U. Because TU is representing gas, so T starts from there and U is at the very end of the graph. Any question? So I repeat that this is a heating curve. To be more exact, it's a boiling curve. Okay, note it down. You got a lot of things to write on your class kit. Okay, like I mentioned, if you need to pause the video, just pause the video. The good thing about this is you can pause the video. Okay, let's move on. Okay, we are done with the heating curve. Let's go to the cooling curve. Okay, the word cooling means temperature must drop. So it's called cooling, not heating. So as you can look at the graph, one look, you know that the temperature goes down. It starts high, then start to drop and drop and drop and drop. Okay, so there are two cooling curves. The first one is called condensation. I hope you know what is condensation. Condensation is gas changed to liquid. The gas condense. Remember? Condensation is gas to liquid. So I start with a gas. You see, when time equals to 0 at 0 minute, at 0 minute, I start with a gas. Okay, you plot the graph. I see it. Okay, I start with gas because I need to condense the gas. So I start with the gas. Then after that, the gas will go through the horizontal part, which was try to condense. So I have a mixture of gas and liquid. Some of the gas already condensed, some of the gas is trying to condense. So I have a mixture of gas and liquid in the center part, the horizontal part of the graph. After that, the next section is all liquid because every gas all condensed already, no more gas already, all cool down, very cooling already, all become liquid. That's the last part of the graph. Okay, any questions so far? So you look at the graph, I want you to draw a dotted line. This dotted line corresponds to the horizontal segment. It gives you a special number. I call this the condensation point. What is condensation point? Condensation point means at 95, if the condensation point is 95 degrees Celsius, it means to say at 95 degrees Celsius, then it start to condense. Okay? At other temperature, maybe 140 haven't condensed, still gas, very hot. 130 still very hot, still gas. Then 120 still gas. 110 still gas. All the way you need to lower the temperature a bit. 100 degrees, still very hot, still gas. Then maybe at 95. The temperature a bit lower already. Then it start to condense. So when it start to condense, you call it the condensation point. And that's 95 degrees Celsius. Okay? So to summarize, condensation point is 95. It will start to condense at 95 also. Okay? AB is a special segment. AB in the middle. Okay, it's a mixture of gas plus liquid. Any question? Yeah. Let's move on to our last graph. Our last graph over here is freezing. I think you know what's freezing. It's liquid changing to solid. You freeze the liquid. So in other words, I start at 0 minute. 0 minute. I start with liquid and I'm supposed to freeze the liquid. To freeze the liquid, the temperature must be cold. So that's why the temperature need to keep dropping, getting lower and lower, like what you see on the graph. Okay, so over here, this is a freezing curve. And if you draw a dotted line across to the special horizontal segment, you realize this number is 45. So I call this the freezing point. Means it starts to freeze at 45. Other temperature, if it's very high, like 80, it's not going to freeze. It's still going to be a liquid. Okay, you lower the temperature down, 70, 60, 50, 45. I think it's cold enough. It will start to freeze. When it starts to freeze, 45 will be my freezing point. So very simple. Freezing point is 45. If you look at the states, starting is liquid, ending is solid. So in the middle is liquid and solid lah. Some of the liquid freeze already. Some of the liquid haven't freeze. So I have two things, liquid and solid in the middle. Okay? Okay, let's look at this question. First question, this is a cooling curve. Okay, because the temperature goes down, it keeps dropping and dropping and dropping. It's not a heating curve. Next, you must read the question carefully. I start with a liquid. So when you start with a liquid and it becomes colder and colder, the liquid, what will happen is the liquid will freeze lah. Oh, it's not common sense. So the liquid will freeze and become a solid. Okay. So over here, you must see that I must start with a liquid and I must end with a solid. So the middle section of the graph, obviously, is a change of state lah. So I have liquid plus solid. It's changing. Okay, the liquid is starting to change to become solid. So state the change at between F and G. F and G is here. What is the change? The change is freezing. Okay, the change of state is freezing. Can. Any question? Okay. What is the physical states of N at this place? E and F. Where's E and F? E is here. F is here. So the answer is liquid. It's indicated liquid. Quite straightforward, right? If you read the question, it starts with a liquid. You must read W2 you forgot to read then there's a problem. You must read. F to G is the middle, so it's liquid plus solid. G and H is at the last part of it. G and H is only left with solid, all frozen already. Any question? Good enough? Can Okay, I'll move on. If you need to pause the video, just pause, okay? Okay, let's look at the exam question. Here is substance X. This was 2 years ago, the question for prelim. They tell you it's a heating curve. Even they never tell you, you also know it's heating curve because you see the temperature going up, you are heating it. So it's called a heating curve. Okay. Next important thing, you must read. I start with a solid. Must read. You forgot this one and hate it. So you go and indicate, I start with a solid. Then you go and heat up the solid, become hotter and hotter and hotter, right? Then after that, of course, it will melt. After it melt, it becomes a liquid lah. Makes sense, right? So in the middle is solid plus liquid lah. It's melting This is melting. This is melting in the middle. Okay. Okay, first question. What is the melting point? So let's look at the graph. where's the melting point? The melting point is where it starts to melt lah. That's called the melting point, isn't it? So over here, you can see melting starts over here, the horizontal. So you just draw a line, a dotted line. Okay, just draw a dotted line. And this number, I think, is 72. Correct me if I'm wrong. But every square is 2. I think so. Every square is 2. So you can count. I think it's 72. Okay, every small square is represent 2. So it's 72. So the answer is 72. If you put like that, it's wrong. Because you haven't put the units. You never put the units. I thought it's 72 cm. Okay, so it's not the case. You must put 72 degrees Celsius. Remember my units. Okay, state the time when substance X starts to melt. Okay, let's look at this time. The time is over here. Okay, you look at the graph. Melt means I must be at the horizontal part of the graph. So you go and check the horizontal part of the graph. You scroll down, scroll down, scroll down. Okay, this is the number. Okay, what is this number? Again, I think every square represents 0.2. You can go and check. I think every square represents 0.2. Right in the middle, this is 5. So I think it's 5.6. Okay. 5.6 minutes. Every small square is 0.2. So it's 5.6. And 5.7, 5.8, 4.9, and 5.6. Okay. Okay, this one is drawing. Okay, at 11, let's look where's 11. 11 is somewhere here. So if you can check, 11 is a liquid. Okay, so you need to draw a liquid. How do you draw a liquid? I got teach last lesson, right? You start the circle in the middle. Start in the middle. Okay, liquid is easier to start from the middle. Why need to start in the middle? Because then I can purposely draw the next circle a bit lower. And after that, I purposely draw the next circle much higher. Then you just go and distort a bit. Next one, a bit lower. Next one, super low. Okay. Then after that, you try to close up the gap. If there's a small hole in the middle, here, there's a small hole. It's okay. Provided the hole is not too big. If it's too big, you can fit one more circle inside. Then you better fit the circle inside. Okay, then you just continue. But every circle must touch one another. Okay, I will continue for you. So make sure I don't see any rows. The adjacent circle to each other, you just make sure one is higher, another one is lower. Okay, every circle must touch each other and try to make the same size. Okay, try your best. I know it's not easy. I also suffering. I also having quite a bit of difficult issues drawing using a stylus. But in the exam, yes, it's pencil on paper. It should be easier. Okay. So just continue. Then continue. Okay. So this one looks like liquid a bit distorted. Some are very high. Some are a bit lower. Okay. Liquid, draw liquid. Don't go and draw other solid or gas. Okay, let's move on. Okay, next question. What is this? I have a gas. It's being cooled steadily for 20 minutes. So this is a cooling curve lah. Okay, it's a cooling curve. And did they say it start with what? I start with a gas. Oh yes, very important. See? Must be. I start with a gas. So let's just start to write. This is a gas. At 0 minute, it is a gas. Start with a gas, Okay, you start with a gas. Then this part, the horizontal part, will be gas plus liquid. Because it's condensing. Okay, let me write down. This part B, part B is condensing. Means the gas is becoming liquid, it's condensing. Then after that, condense finish, now it becomes liquid. After that, the temperature still getting colder and colder. The liquid will start to freeze. It's liquid plus solid. I call this part the freezing. Freezing, because the liquid is getting colder and colder, is freezing. It will start to freeze. So there's a mixture of liquid and solid. Okay, after that, the last part is solid. Everything frozen already. Can? Any question? I know this is an MCQ, but you must understand this is a very special graph. Got two horizontal line one. I repeat, there's two horizontal line. A bit special. Previous one, or you check, only got one horizontal line. So got two. That means got condensing and freezing. Okay, all in one graph. So the question asks, where is freezing? So answer quite simple lah. Oh, where is freezing? Freezing is here. Answer is D. Okay. I know you can press the button you see the green box, but make sure you know why is the answer D. Okay, let's move on. Question 3. Okay, this was last year end of year, 2023 end of year. Okay, I have a substance also trying to cool. Okay, last year one, gas. Okay, this is start from gas. Yes, better read the question carefully. What is the thing they start with? It start from gas. So just continue the story. It start from gas. Okay, then after that, here is gas plus liquid because the gas is trying to condense in the liquid. After that, condense finish, all become liquid. Then the liquid will still getting cold and cold and cold and cold. So it will go through freezing. So this part is liquid plus solid. After it freeze, everything finish, the last part is solid. Must read carefully the question, what it start with. Okay, between which two letters on the time axis is there only solid? No other things, only solid. So the answer is very simple. It's L and M. I hope you can see. I change the color. Red. L and M. Is the one only has solid. Okay, I hope you know how to get solid. You just go with the story lah. Can you start with the gas, then the gas condense, become liquid, then liquid condense, liquid freeze, become solid. Okay, name the processes. What is processes? That means I don't want you to tell me what liquid solid. I want you to tell me the process. Is it freezing, boiling, or what? Okay, all these are the processes. So you tell me the processes. Can. So at temperature F, where is temperature F? Let me change my color of my pointer. Okay, F is here. So at F, you check at F, it is this thing. This thing is condensation. So condensation is taking place at F. The temperature, I don't know what temperature lah. Maybe 40, 50, I don't know. They never write the numbers. So at temperature F, the thing is undergoing condensation. So just tell me condensation. Condensation is taking place at temperature F. It simply means the gas is turning into liquid lah. It's getting colder and colder. The gas is condensing, it's becoming liquid. Okay, the next one is at G. So at G, if you check carefully, what's happening at G? G is this. This is liquid and solid. It is freezing. Alright, my liquid is becoming solid lah. So it's freezing. It's not boiling because the temperature is getting colder and colder and colder. The temperature is dropping. How can it be boiling or melting? No, doesn't make sense. If you want to melt something, it must be hotter. Want to boil something, it must also be hotter. This one is colder. So it has to be freezing. Liquid and solid. Liquid turning into solid is freezing. Any question? So far so good. Can? Okay, no question. I will stop share. But make sure, I repeat, make sure you complete my class kit. I'm not going to return back to the next lesson and go through this again. Okay, so my class kit, set number 11. This is set number 11. Yes, set number 11 must be done, completed. Okay, the good thing about this is a recorded video. If you miss anything, you just rewind, go back, you can find the thing. No issue? Okay, no issue. I will stop share now. Okay, very good. Done? Okay, any questions? When I go back to school, I go back to the class for next lesson, they ask me, I will now stop the recording.